In this web talk, I show how to use Mplus to do multi-step mixture modeling for latent transition analysis. This is joint work with Tiamar Asparahov. Multi-step mixture modeling concerns techniques commonly referred to as 3-step, BCH, and 2-step. The presentation illustrates several new Mplus features for these techniques that are included in Mplus version 9. Webtalk 10 is the third part of the trilogy of web talks on multi-step mixture modeling. Webtalk 8 discusses latent class analysis, and Webtalk 9 discusses new techniques to include direct effects for latent class analysis to capture measurement and non-invariance with respect to covariates. The extension to latent transition analysis in Webtalk 10 relates most closely to WebNote 21, but provides a much less technical account. It highlights Mplus syntax and special Mplus modeling features. Webtalk 10 assumes some knowledge of regular latent transition modeling using Mplus, that is, not using multi-step methods. Background for such regular latent transition modeling can be obtained from Webtalk 2. Analysis illustrations use simulated datasets that are available for practice. Key Mplus runs are included on the website of the talk. Here's the outline for the talk. We start with a reminder of a regular latent transition analysis, and then we turn to the multi-step area, where we're going to focus on distal outcomes and covariates, and with a special feature of missing data on the covariates. We're going to talk about the three common methods, 3-step, BCH, and 2-step, but with a special feature of imputations to handle the missing data on the covariates. We're going to take a look at the inputs in detail and the results. Then we turn to specific topics of LTA. We can take a look at transition-specific distal outcome means. So we're interested in the transition, so we may be interested in how the outcome means change for certain transitions over time. And we're going to introduce the so-called dot language, which turns out to be quite flexible. We're going to turn to the issue of empty cells and the problem of BCH failure in some context. Then we turn to multiple group LTA and the random intercept LTA. And then we end with latent class analysis at 2 time points and take a look at how that is different from LTA.